Good morning, students. Today we will discuss the assignment number 9 with the CL8 lab, Computer Lab 8. Already we have discussed different UML tools. In this diagram, we are going to discuss regarding how to implement the design patterns. We have discussed different design patterns, but for this assignment, we will discuss what is GOF. So let us discuss what exactly is GOF, why this is called as GOF. So one by one, I will share with you how to implement a program in Java for this GOF pattern. Basically, you start with the assignment. This is your assignment number 9, identification and implementation of GOF pattern. So, experimental level outcome is design and implement GOF pattern. What is the aim? Map the participant for the state design pattern from given problem description and implement with suitable object-oriented language. So basically, you can see here state design pattern. There will be many design patterns. We will discuss one by one, but in which we are going to implement a state design pattern. What is the intent behind the state design pattern? Allow an object to alter its behavior when its internal state changes. The object will appear to change its class. An object-oriented state machines. We are implementing here a state pattern. So take any monolithic object behavior and its function with different states. It must change its behavior at the runtime depending on in what state it lies currently. So an application is characterized by large and numerous different statements so that we can observe on the state of the application. So the state pattern allow us to object alter its behavior when its internal state changes. The object will appear to change its class. That is important. So who has defined this state pattern? So the name is Gang of Four. Actually, Gang of Four are these four authors in 1994: Eric Gamma, Richard Helm, Ralph Johnson, and John Pilstridge published a book titled Design Pattern Elements of Reusable Object-Oriented Software, and which has initiated the concept of design pattern in software development. So these authors are collectively known as Gang of Four. As four authors are there, so the name is GOF, Gang of Four. So according to these authors, design patterns are primarily based on the principle of object-oriented design. So program to interface, not an implementation. Favor object composition over inheritance. So these are the important principles. We are trying to write more interface so that we can easily collaborate. If object changes its states, object can run freely through the interface, not exactly with the implementation. And then instead of using inheritance many times, now it is focusing on object composition over the concept of inheritance. Then basically the types of design patterns are 23 total design patterns, which are classified into three categories: creational, structural, and behavioral patterns. One more category now come emerging, that is J2AE design pattern related to the Java. So what basically the creational patterns? Creational patterns are these design patterns provide a way to create objects while hiding the creation logic. Rather than instantiating the object directly using a new operator, this gives program more flexibility in deciding which objects need to be created for a given use. So there are certain types under the creational design patterns like singleton pattern, prototype pattern, factory method, builder pattern, abstract factory method. You can implement these patterns in Java or C++, any object-oriented programming. Then in the structural patterns, these design pattern concern class and object composition. Concept of inheritance is used to compose interfaces and define ways to compose objects to obtain new functionalities. Here, some of the types of under-structural patterns are proxy pattern, flyweight pattern, composite pattern, breeze pattern, packet pattern, and decorative pattern. One more is adapter pattern. So, last one is the behavioral pattern. These design patterns are specifically concerned with the communication between objects. So observer pattern, strategy pattern, template method pattern, command pattern, iterator pattern, memento pattern, state pattern, mediator pattern, chain of responsibility pattern, visitor pattern, interpreter pattern comes under behavioral pattern. And J2EE pattern, these design patterns are specifically concerned with the presentation style. These patterns are identified by Sun Java Center. So specifically, Sun supports this J2EE kind of pattern. In this assignment, we are going to implement state pattern, which is comes under behavior pattern. So which actually shows the communication between objects. So what basically this state pattern is? It is a behavioral pattern like a strategy pattern where it uses composition to encapsulate behavior that must change at runtime. So in strategy pattern, this encapsulated behavior or actions are dependent on context object's current state. When a certain action is requested of the context, it simply delegates to its state reference, which takes care of determining how to the best handle a particular request. The state will take into account any rules for how it should respond to such a request. In state pattern, a class behavioral changes based on its state. This type of design pattern comes under behavioral pattern. In state pattern, we create objects which represents various states and a context object whose behavior varies as the state object changes. So to start with the implementation of the state pattern, we need to create some interface and some of the classes. So here I have took the example of online grocery shopping. As in the previous assignment, we have already discussed how to implement UML diagram for online grocery shopping. So basically, here we have considered a product state. When a product is ordered online by the customer, what are the different state a particular product is going through? So we need to demonstrate those states by using state pattern. So basically, we need to implement one interface. When you start implementing state pattern, we have to first create interface class. Through that interface class implementation, we can show how the object's behavioral change when it going from one state to another. So we have first created a class interface product state. What are the different state of a product when we purchase a new product online? So states of the products are product order. When it is reached at the transit hub, it is initiating with the delivery, out for delivery, then product received by the customer, then status of shipment, whether shipment is delivered or not. Then last is order closed by the administration order. So these are the different state where object at run at particular time interval. For that, in the first step, we have created a class interface product state, which defines the state of the products, and the methods under this interface are next, previous, and print status. Then in step 2, we will create a product class which invokes the object of order state class and defines method of all the states like deliver, order, shipment, all these are defined. Then we create one more class order state which implements product state interface, and we define the deliver state and a route state, initial state of the products. Where in the next class deliver state class which implements again the product state interface, but it defines a method of receive state class and product state interface. Next class we need is a receive state class which implements product state interface and defines a method for deliver state. And finally a demo class which demonstrates all the states of the product like delivered, received, to show the product object how it travels between all the states. So total 6 Java classes we need here. One by one we will check how to run this particular code. Output expected for this assignment is just print the state of the product at a particular time interval. So first product is in a root state, second product order but not delivered to the customer, then product reached to the nearest transit hub, initiating out for delivery, product is out for delivery, then product received by the customer, status of shipment is deliver, status of order is closed. So for a product object, how different state changes, that is nothing but a state pattern we will implement. For implementation, I have used the NetBeans interface. You can run with any Java editors. You can use Eclipse also, or you can create a simple Java files, but put one package from all files under one package so that you can execute it properly. So I will share with you the interface of NetBeans. So basically, NetBeans I have used here. Just check. This is the NetBeans interface. So to run with the this is your NetBeans interface. To run with the new project, go to File, click on a new project. Here you can select a Java application. Give the name of that application like online shopping and click on a finish. So you will get a new project here. So when you get a online shopping here, you need to add different classes. As we have seen that we need the first interface class, that is product state. So just click on a default package, make a right click, new Java interface. If you click on a new Java interface, just class name appears, new interface. Give the name of that interface like a product state and click on a finish. So you will get a product state class. You need to define in a product state the three operations next, previous and a print status. So this particular interface gives you the current position of the object of the product at which position, what is the next state, what is the previous state, and print the current state, current status of your product. So this is the interface class we need for a product. Then you need to design class product.java. So again, make a right click here, click on a new Java class. You can define a class name here and click on a finish. You will get the product.java class. Here, for the product class, you need to define the product state object, that is the state. Private product state equal to new order state. And here you define all the state of the product, like public void previous state, state dot previous. You need to pass the this object as it returns to the current object position. Then public void next state, again you need to pass state dot next this. Then for printing, public void print status, state dot print status. Then what is the set state we want? We need the deliver state object to define the state of the object. So state is equal to new deliver state. Then all the state of deliver, order state and receive state. We are creating the object here inside the product class to define the different state of product. Then we need to implement these classes: deliver state, order state and receive state. So create different classes by clicking scene, default package, new, go to Java class. Define first is the order state. So basically in the order state you will get the public class order state implements product states. While defining all the state, you need to implement the product state, which is the interface. So public void next, you need to pass a product pkg, the object of product class, because here how we are going to show object in its states. So basically how this product object pkg in what state, we need to define its state. So pkg state, set state, new, deliver state. Then pkg with the what is the order state. So when we are in the order state, the next state will be the deliver state. Then if we want to define its previous state, just put the message the product is in root state. So what is the, this is the class order state. What is the previous state? Is a root state of the product. And what is the next step? It must be a deliver state. So we are creating one object here. Set test is deliver state and previous state in a print test. But what is the current state here? When we are creating a class product state, the current status of the object is product is ordered but not delivered to the customer. So we are defining this class as the order state class. Previous is the root state, next is the deliver state, and now the class object is in the order state, that is it is product is ordered but not delivered. Then similarly, we create the receive state class. You can see here, again we are defining the product interface, product state interface. What is the next method in a receive state? Product out for delivery, but product received by the customer. What is the previous state? Previous state is the deliver state. We need to first check the delivery before receiving it. And what is the print status? Status of shipment is deliver. Status of order is closed. So it is the received state. Then we can check what exactly inside the deliver state. Deliver state implements again the product state interface. The next state of the deliver is receive state. Then the previous state is the order state. And what is the print status? Product reach nearest transit hub and initiating out for delivery. After that, if you want to show all the state demo together, we are creating a new class state demo. So inside which we are creating the object product pkg equal to new product, and this product pkg we can see here is passed throughout the all order state, deliver state and receive state. So here we are defining a state pattern for one object of the product class. So basically then pkg previous state is just it called by the product state interface. Here we can check that product pkg and product previous and print status, these are get executed when we are creating this with the package dot set test. We are defining this. So basically in a product class, then we are passing this. Just check here, public void. In a product class, we have defining all the objects. Product state is equal to new order state, and that state object we are defining previous next print status. So when in a state demo code, when we say pkg dot previous state, it goes to the product.java and start executing its previous states, next state and a current state. So if you say pkg previous state, print state, next state. Then again for the different level we are executing for next state and print states. If you want to print the next status, accordingly it will print. So this is the sequence of different state of the package object. To run this file, you can start directly compiling and build this file, and you will get the output. So in the output window, you can see here what are the different state. First, the product is in its root state. So when package.previous state get executed, we say the product is in root state. The print status is product order not delivered. So when it is in the after that package.next states will give the product reach to the nearest hub initiating out for delivery. Then for the product out for delivery, one of the status, then we can say here product received by the customer, status of the shipment and status of order is closed. So this particular object status is end when status of order gets closed, and that parts come under the part received status of order here, received.java. You will get status of shipment is delivered and status of order get closed. So this is the product object, and you can implement for different state of the object at the current time or a real time. So this is the assignment number 9, how to design a state pattern. This is a behavioral pattern under GOF. So this is your code. You need to define total 5 classes These are the classes of the state. Suppose you are implementing with a state machines, any kind of a machine, you can define your start state, stop state. Or if you are working for a washing machine, so you say washing machine state.demo, create an interface where you say washing machine state.java. And if for washing machines, if you want to define 2 or 3 or 4 states, you can define start state, stop state, rinsing state, washing state, drying state, and you can create those mini Java classes for each of the state. Create one demo class.java, and in which you call all the functions which we have defined inside all the state. Try to use this pointer which points to the current object positions. When you define a state pattern, try to use this pointer so that it is point to the current state of object. So this is your assignment number 9, design of state pattern.